Thank you. Let me check this one. It's way different from the first one. It is another study group with me and my study group from Middle East Technical University in Ankara. Me and my student Minat Deniz Enderya develop a study to develop a smoke wire flow visualization technique applied to the fluidic thrust vectoring system based on the coanda effect, which is developed by Henry Coanda. And this is me again. You can check. I will not go through it again. So the outline of this study starts with the smoke wire visualization technique, and the objective of the study and the experimental setup will be given, and the methodology of this technique will be shortly addressed, and the results of this visualization technique will be given in pictures. And lastly, there will be a conclusion section and acknowledgements references will be added at the end of this presentation. It will be a little shorter when you compare with the first one. So in the experiments of the visualization, smoke wire, which is one of the techniques for visualization flows, was employed. The technique is selected here for its minimal impact for the flow. There's no physical standing part, only there's a wire. There's in millimeters. It's very small. It is 0.2 millimeters in thickness, nickel based. So its efficiency at Reynolds number below 775,000 is generated by Özkan in 2016, and its cost effectiveness is checked by LIM in 2012. So it's selected in our study. The visualization will be achieved here by creating smoke lines in the flow field through the generation of smoke by combustion of the hydrocarbon-based machine oil, which is paraffinic oil, with the assistance of electrical current on the wire positioned in front of the electric ducted fan. In short, it is EDF. The flow was instantaneously visualized with the aid of digital camera, simple camera. The diameter of chromium nickel wire is recommended to be 0.2 millimeter in literature. So using these three references so that we select this one. And the objective of the smoke wire flow visualization to observe the behavior and trajectory of smoke lines here in figure 1. However, it will not be feasible without specific thrust. So we should select a specific thrust to develop these lines. We will have a look at these lines at the end of the slides as a video. So for this experiment, an electric ducted fan, EDF, which is controlled by electronic speed controller, ESC, was employed, directed at the specific distance so that we can see the direction of the flow because of the coanda effect, because of the shape of the body, which is also given in the reference here, Kara and Kurtuluş, me and my colleague. And this is a simple experimental setup. The EDF was utilized. There is a EDF part on the left, but it is given. It's not given here. So there's a big part here. It is given in the next slide, I guess. So the preparation phase is this one. So we have the unit here at the back, which is a big, large EDF, electric ducted fan unit, which blows the air through this opening. And there is, you can see maybe the initial stage of the process, the entails the introduction of this oil through the syringe. You can also make it mechanical, but we make it by our hands. And we have the experiment parts servomotor system here, which is connected to the computer in an Arduino-based system. And the wire should be extended using the motors. There are two motors here and there. So it make the correct tension of the wire so that we can flow the oil over the wire easily. And the current cables, these two are used, which are connected to the wire in both sides. And in the other side, we have a power supply so that we can heat up the wire. And the methodology starts with the pressing of the oil from the syringe to the oil line and followed by the release of a few drops. Power supply is then activated along the cable to warm up, and EDF1 is switched only after the smoke dissipated. Here, smoke starts. Then when it is dissipated, we said it is now ready to open the system. The post-experimental phase, it begins with the disconnection of all power connections. Once the wire is cooled, you should replace it. Find all the spilled on the body is cleaned. So this is the post-process. So step-by-step close-ups are given. And the following is giving the detailed account of the methodology. We have the steps of initial preparation and conclusion of the experiment. So you can see in the first one, the result of the flow visualization are presented. Figure 6 here shows the initial formation of the smoke. Here you can see the initial formation. Let me show here. Yes. So it is the initial smoke formation here. Then we have the burning the oil. You can see after the initial formation, there's a burning oil over the surface. And you can see when you open the thruster, which is the EDF one, so the movement of the smoke is shown. And the figure 9 shows smoke after the EDF one has been started now. Then you can see the movement of the smoke after the thrust has been applied. And this is the same direction of the flow, which is the same direction when you compare with the surface. They are the same directions. So basically, as I said, this is a short presentation when you compare with the first one. This study examines the distinctive approach to visualization of fluid flow, which is smoke wire flow visualization. This was a part of a student project, by the way, in the undergraduate level, but we increased the level of it. With the final experiment setup in conventional cases, it's relatively simple. Integrating novel systems requires attention to detail, so it is the beginning of the study. This presentation outlines the iterative process of conceptualization, configuration, and refinement of the smoke wire visualization technique. And this study exemplifies the pursuit of extracting optimal insights for fluid dynamics through visualization methods. This work is financially supported again by Gaziantep University under the project number 2102. And 3D printing, laser cutting processes are completed in Fab Lab Application Center. You can check references here. And also these are the daily videos are not starting. There should be videos here. Let me show videos here maybe. Videolar ne başladı anlamadım. Şunu niye başlamadı anlamadım ama başlamadı mı? Can we use this one?
Okay.
Oh. Maybe this is because we are
Yes, we are sharing stream.
showing the stream.
I think that's the problem.
Maybe we should enable the content. Oh, this one is a problem. Now it started, I guess.
Yes.
No. So you can see the drop of the oil and start of the process. Then you open the fan so that you can see the direction of the flow in a slow motion. And also we have pressure computation, calculation, collections, but this is not the part of this presentation. So thank you for your attention. You can reach me from email and the other resources.